Today we will be learning how to differentiate a sine function using the first principle. Check our previous video on the first principle. If you have a given function y equals sine x, differentiating this, written as the y, differentiating the y function with respect to x is going to give us another trigonometry identity referred to as cosine, written as cos. So in this case, it's going to be cos x. But how do we arrive at this? I'm going to be taking you through using what we call the first principle. And the first step is, remember, you had an increment to both variables. Okay, so we have in this case, make an increment to y. We use the symbol known as change or delta. So we have delta y. So it's equals to sine. We have x and make an increment to that using delta x. And the next is to make delta y subject of the formula, and this gives sine x plus delta x. This y comes to the right side now to give minus y. And we have our delta y equals sine of x plus delta x minus y, which is originally given as sine x. So we have sine x. To do this, what we're going to do now is to remember in trigonometry, there is a trig identity like this. The sine of a plus b is going to give you the sine of the first, sine a, the cosine of the second, cos b, plus the cosine of the first, a, and the sine of the second, b. So if we apply this to the first term here, sine x plus delta x, we're going to have sine, the first one, x, cosine delta x plus cos x sine delta x. That's for this, the first term, and we still have the second term minus sine of x. There are three terms here, and we can see that the first term and the second term have common terms, which is sine x. So by that, or factorizing that, we can have delta y equals, if we pick sine x from the first and second and third term, we'll be left with cosine of delta x minus sine x, factorizing this sine x here, will be left with 1. And the second term, which is plus cosine x sine of delta x. Our interest is to get at something like this, differentiation of y with respect to x. So now we have our delta y, so we can divide both sides by delta x, and that is going to become delta y over delta x to be equals to, from our previous lesson learned on first principle, we know that when you limit at this stage, when you limit delta s to 0, that is, as delta s tends to 0, we are aware that we have so our delta y over delta x, which tends to, it becomes the differentiation of y with respect to x. We are also aware that the cosine of delta x minus 1 over delta x will tend to 0. And lastly, we know that the sine of delta x over delta x will tend to 1. Yeah, we can prove this, but it's beyond this lesson. In probably one of our videos, we're going to show how to get this 0 and this 1. So for now, take note that this is a generalization and a standard. So with this, we can go ahead to have dy ds. So if we look at the first term from here, this is a first term, you can see that. So we have the sine x, so I have sine x out, okay, and its product cos delta x minus 1 over chain delta x, which is this part, as tends to 0, so we have this, plus, then go to the second term, the next term, we have this cos x, I can have cos x, and I'm left with sine of delta x divided by delta x, which tends to 1. So we have this as 1. And from here, we can say our differentiation of y with respect to x gives us this is 0, and cos x times 1 is cos x. So, and that is it from first principle. When you differentiate sine of x, you'll get written as y prime or d of dx to be cos of x. Thank you.